Now we come to IWA. We will discuss the following topics to introduce the new offering IWA that will be available as the Informix Ultimate Warehouse Edition, IUWE, according to the IDC article, and subsequent articles from Gartner and Forrester. We are now entering the third generation of database technology. The first generation systems like IMS had very rigid procedural, or navigational, requirements to retrieve records from the database, thus making applications not portable to other systems. That is, program written for IMS cannot be used for IDMS. The second generation systems use SQL extensively in open systems environments and are non-procedural, that is, making use of optimizer to determine an optimal access path. However, these systems' performance is limited to disk layout of the data and how efficiently we can do I/O. Over the years, we have added many techniques to optimize I/O by using indexes, partitioning, summary tables, multi-dimensional cubes, query rewrites, etc. All requiring much expertise developed over the years to tune the system. Yet, there are still many instances of runaway queries and IT staff is still worried about load windows or reporting windows that have to be met. The paper argues that a third-generation database technology is here that uses mostly in-memory, columnar technology to eliminate I/O, not reduce it. And with new advances in commodity hardware, scaling can be achieved with clustering. Furthermore, OLTP and data warehousing can coexist on the same system in an economic way. IWA is an integration of IBM hardware, software, and storage and advanced technologies focused on business analytics that combine to give IBM clients the industry's most high-performance analytic capability to extract business insight from information assets, providing the right answers to the right questions at the right time. It marries the best of row and columnar store technologies with a highly compressed data, in-memory, massively parallel architecture. It removes the costs of traditional performance tuning such as indices, materialized query tables, MQTs, and query plan tuning that required extensive time and expensive resources. It is optimized for full table scans, the most common BI query access pattern, that enable customers to get quick and predictable results to gain business insights. It enables queries that have been removed from the system in the past, due to their long-running, high-resource requirements. Listed are the key technologies involved in providing the major speed-up in query response, which will be discussed further later in the presentation. We will explain each of the technologies including deep columnar technology, extreme compression later in the talk. Query flow of Informix and IWA is the following. Informix users continue to submit queries either directly or via a BI tool like MicroStrategy, Cognos, etc. Informix Optimizer decides which query, or query block within a query, can be routed to the accelerator. Accelerator returns the answers to Informix, which then gets returned to the user. Note that the Informix database, or warehouse, stays the same and is still kept on the Informix side. There is no database on the IWA side except what is loaded in memory. Local disk on IWA only serves to provide a memory image in case of failure. Internally, IWA spawns a coordinator process that manages the loading, the execution of the queries. It also assembles result set from the various worker processes, which does the bulk of the work. Parameters are available to specify the amount of memory used by the coordinator and worker processes. Parallelism is still achieved with minimal worker processes. The sweet spot for IWA is data warehousing queries, in the form of star schema or snowflake schema. These queries typically look for trends and exceptions. They touch large subset of the fact table and involve aggregations. Designers specify what tables compose of the data mart using the Smart Analytics Studio graphical environment. Informix will offload data belonging to the mart to IWA. This is a typical query against the star schema you see on the previous page. It usually involves a fact table and joining with the number of dimension tables, followed by aggregation, grouping and ordering. One of our early validation program customers, a major shoe retailer in the US, did testing comparing the use of Informix 11.5 versus IWA. The database contains 1 billion row fact tables and a number of smaller dimension tables for their sales and inventory analysis. It took about 30 minutes to load the data. As shown, each of the most problematic queries returned in 2 to 4 seconds. Computer used for this experiment was an IBM X3850 with 24 cores and 256 GB RAM. Another early validation program customer is a large government agency in Europe. Queries were submitted via MicroStrategy. This is their most complex report involving hundreds of SQL statements. On the Intel box, the report timing went from 40 minutes to a little over 1 minute. Third early validation program customer is a U.S. government agency. Again with impressive